Physics has a speed limit. Beat. And our copper wires just hit it.
Which is exactly why we're seeing this massive $7 billion shift to light-based chips.
Yeah.
It's quietly changing the entire future of automation.
Welcome to the deep dive. We have a really fascinating stack of recent newsletters and articles today.
Yeah, lots of great stuff from AI Fire.
Right. They're focusing heavily on AI productivity right now. The mission today is to decode a massive paradigm shift.
It's happening right now, basically under our noses.
We're moving away from simply typing prompts into a chat box.
Right.
We're moving toward building self-reliant, autonomous AI systems.
It's a huge leap.
And whether you are a solo entrepreneur scaling up or you're just trying to survive information overload at work, this deep dive is your shortcut.
Absolutely.
We are looking at exactly how the top 9% of users are making AI work for them.
It really requires a complete inversion of how most of us approach our daily workflows. I mean, we're moving from manual intervention to entirely automated thinking pipelines.
Right. We keep talking about building these massive autonomous AI pipelines, but there's a physical elephant in the room here.
The hardware.
Exactly. We cannot truly understand the software revolution without looking at the physical hardware powering it.
Yeah.
We are literally changing the physics of computing right now.
Yes, because we are hitting a very hard physical wall. NVIDIA just made a massive move to bypass that wall.
Right.
They placed a $7 billion bet on a completely new architecture.
I was reading through the notes on this, and the bottleneck itself is fascinating.
It really is.
Copper has finally hit a physical limitation. Our data simply can't move fast enough anymore.
Yeah, the electrons can only go so fast.
Think of traditional copper wiring, like trying to push water through a narrow pipe.
Right.
Eventually, the friction causes the pipe to burst from the immense pressure and heat.
And the heat is the real killer for these massive data centers.
Wow.
It's not just about physical space on a motherboard. When you push that many electrons through copper at those speeds, you get massive thermal resistance.
Yeah, that makes sense.
The data centers are literally choking on their own traffic. They can't cool down fast enough to maintain the computation speeds we're demanding.
So NVIDIA is essentially ditching electricity entirely for these new pathways.
Exactly.
Using photons instead of electricity to move data instantly.
That completely bypasses the thermal limits. Photons do not have that same physical friction.
Right.
Light-based chips are like shining a laser pointer across a room. There's zero physical resistance.
It's just teleportation compared to a congested city highway.
Yeah. There is no crippling heat generation. There's just the immediate, instantaneous arrival of the signal.
Which unlocks unimaginable processing speeds for these new AI models.
It changes everything.
But that kind of speed introduces a terrifying new variable.
Oh, for sure.
I was looking at Jensen Huang's recent game-changing announcement at GTC. He unveiled something called NemoClaw.
Right.
It's designed to fix OpenClaw's biggest vulnerability. It basically acts as a digital cop for your AI workers.
NemoClaw is arguably the most crucial piece of this new puzzle.
Really?
Oh, yeah. When you have agents operating at the speed of light, the damage they can do in a fraction of a second is catastrophic.
If the hardware is getting so fast, why is a security tool like NemoClaw suddenly the headline?
Because autonomous agents act independently now. They aren't waiting for your approval.
Oh, wow.
Without a hard-coded digital cop observing the network layer, ultra-fast AI could instantly execute a catastrophic mistake.
Like what?
Well, it could hallucinate a command and blast your proprietary internal files across the public internet in milliseconds.
That is terrifying.
NemoClaw stops that. It's a hard-coded protocol that intercepts outgoing actions. It prevents these agents from leaking data or acting maliciously on their own.
Right, so NemoClaw is a bodyguard keeping agents from leaking our private files.
Exactly. It provides the necessary friction. You desperately need guardrails when you're driving at the speed of light.
Yeah.
It ensures absolute security without sacrificing the performance of the new hardware.
So the foundation is set. The hardware is incredibly powerful, and thanks to tools like NemoClaw, it is highly secure. Because of this massive leap, the old way of using AI is fundamentally broken.
Just typing a question and waiting for an answer? Yeah, that's dead.
The software side absolutely has to adapt to this new reality.
If you're just using an AI as a glorified search engine, you're vastly underutilizing the technology.
The AI Fire newsletters emphasize this heavily. The top 9% of users don't prompt anymore.
Right, they build systems.
They use something called the reverse method.
The reverse method completely flips the traditional dynamic. Normally, you write an instruction and hope the AI guesses what you want.
Yeah.
With the reverse method, you start with the perfect desired outcome. Then, you engineer a system backward to guarantee that exact result every single time.
Let's ground this for the listener. Instead of saying, write me a marketing email, you feed the AI your 3 highest converting past emails.
Right.
You say, extract the psychological triggers used here, then build a prompt that forces you to use these exact triggers for any future product.
Yes.
You are building the mold, not just asking for the cake.
That is a brilliant way to frame it. You're forcing the model to understand the underlying architecture of success, rather than just generating a superficial imitation of it.
I have to admit, I still wrestle with prompt drift myself.
Oh, we all do.
You write this incredibly detailed multi-step paragraph. You hit enter. And by the third output, the AI just forgets half of what you initially asked.
It's the inherent flaw of the mega prompt. Large language models are fundamentally designed to predict the next most likely word. Over its long enough conversation, their context window gets muddy. They regress to the mean.
Yeah, they default to a highly generic, averaged-out response that sounds like corporate speak.
Exactly. That brings us to the specific framework they outlined for 2026.
Stop trying to replace entire employees with one single chat window.
Right. Instead, you break any business function into individual granular tasks. Then, you rebuild it as an AI-driven pipeline.
This is a crucial shift in workflow design. You do not ask one single AI instance to write an entire marketing campaign.
No, that's guaranteed to produce bland garbage.
The sources mention that specific frustration. ChatGPT and Claude often repeat the exact same generic ideas, just disguised with different vocabulary.
Yeah.
The proposed solution here is deploying sub-agents.
Sub-agents are the ultimate cure for that generic AI voice.
Really?
Oh, yeah. Instead of one monolithic model doing everything, you're creating a specialized, highly focused committee.
How exactly do smaller sub-agents stop an AI from just repeating the same generic ideas?
Well, giving specific narrowed tasks to different AI agents forces unique perspectives. You give them deliberately conflicting goals.
Interesting.
You have one sub-agent optimized entirely for wild creativity. You have another optimized strictly for factual accuracy and brand voice.
And they talk to each other.
They debate each other. This friction prevents one homogenized average answer from ever reaching you.
Got it. Smaller bots handling specific tasks stops the generic robot answers.
Yes. You are essentially engineering friction into the software layer.
Right.
Just like NumClaw is the necessary guardrail for hardware, these specialized sub-agents act as the guardrails for quality output.
Okay, so once you break your workflow into these specialized sub-agent pipelines, you have to connect them to the outside world.
Right.
And according to the sources, this is where the real magic happens.
The outside world is incredibly messy. It requires serious, robust architecture to navigate.
Yeah.
This is where the concept of the 7-layer autonomous workforce comes in.
The newsletters outline a very detailed guide to something called Claude Cowork. This is not just a simple browser tool.
Not at all.
It's a 7-layer system that runs tasks quietly in the background, 24/7.
Most people still use Claude as a simple sounding board. They bounce ideas off it. But this 7-layer setup functions as a shadow corporate structure. It has distinct layers for memory ingestion, task routing, and execution.
Let's walk through what that actually looks like.
Yeah.
The system has a memory layer that recalls past interactions and client preferences. It has a routing layer that decides which specific tool or sub-agent is best suited for the incoming task. And it has an execution layer that actually does the work.
And it does all of this without you ever opening a laptop.
Wow.
It reads the incoming email, routes it to the correct sub-agent, pulls the historical context from the memory layer, drafts the response, and executes the final action.
It achieves this using bridge tech. This setup links your 7-layer assistant to over 8,000 different external apps.
Yeah.
It's like stacking Lego blocks of data.
That level of deep connectivity is the real game changer here.
Yeah.
The AI is not isolated in a silo anymore.
Right.
It reaches directly into your CRM, it updates your calendar, it manages your Stripe account.
They specifically highlight a platform called HeyGen in the sources.
Oh, yeah.
These are no-code templates that allow personal AI assistants to handle actual complex work.
Right.
Crucially, they remember context over time without falling apart.
Memory retention is usually the very first thing to break in standard automations.
Why is that?
If a client changes their mind mid-thread, a rigid automation completely breaks down. NNN solves this by storing the context state outside of the AI model itself.
The sources show actual proof of this in the wild. People are using these specific Claude agents to run solo businesses.
Yeah.
They're consistently hitting $10,000 a month.
Yeah.
And they're doing it without hiring a single human employee.
It completely rewrites the economics of starting a digital business. Your profit margins become nearly 100%.
Right.
The AI is handling the initial client intake, it's managing the fulfillment pipeline, and it's handling the billing automatically.
2-sec silence. Whoa. Imagine scaling to 1 billion queries without human input.
It really is staggering to think about. You are building a highly profitable enterprise entirely out of autonomous thought and connected code.
What makes a 7-layer AI system different from old-school, rigid automations we've used for years?
Well, older tools just follow simple if-then triggers. They instantly break when anything unexpected happens.
Right.
This new system adapts, thinks, and retains long-term memory to solve highly dynamic problems.
It actively thinks and remembers context rather than just blindly following rigid triggers.
It possesses true agency. It observes its environment, weighs historical context, and decides the best course of action without waiting for a human to push a button.
We're going to take a quick break. Mid-roll sponsor, Reed.
And we are back.
Ready to jump back in.
So if an AI can smoothly operate across 8,000 different apps to run a business, there is a very logical next step.
Yeah.
The final inevitable step is the AI learning to build the apps itself. It improves itself completely alone.
This is the absolute frontier of what we're tracking. We are rapidly moving past AI as a helpful assistant.
Right.
We are entering the era of self-evolving AI. The newsletters dive into a very radical concept here. The quote that stood out to me was, AI doesn't need you now. It acts on its own.
It's a sobering thought. It challenges our entire role in the digital economy.
Definitely.
But the recent data from Google AI Studio backs up that claim entirely.
Google just released a massive full-stack update. You can now go straight from a single text prompt to an entire fully functioning startup.
Yeah.
Literally no developers are needed.
And we need to clarify what full stack means in this context.
Yeah.
It does not just write a little bit of code.
Right.
The system autonomously provisions the back-end servers. It designs and implements the front-end user interface.
Wow.
It sets up the complex database schemas. It deploys the entire stack to the web, all autonomously.
You are just the visionary at that point. You just provide the initial spark.
Exactly.
Which brings us to Minimax. Their new model, called M27, has officially entered a self-evolving era.
Yes.
The results they publish are shocking because this model actually trains itself.
Traditionally, human engineers had to spend months curating massive, incredibly expensive data sets to train these models. They had to manually guide the learning process. Minimax's M27 fundamentally changes that dynamic. It generates its own synthetic data.
It's basically playing a massively complex game against itself to discover novel solutions.
Yes. It creates its own test scenarios. It grades its own performance on those tests.
Right.
Then it actively adjusts its own neural weights on the fly to improve. The improvement loop is entirely closed off from human interference.
The sources note Apple's internal reaction to this rapid evolution. It was categorized as a "what a effing joke" moment of pure disbelief.
Even the engineers at the biggest tech giants on the planet are struggling to comprehend the sheer velocity of this change. When algorithms utilize self-play to compound their intelligence, the growth curve becomes exponential.
If models like M27 are training themselves, how do we even measure their limits?
Traditional human benchmarks are failing completely. Yeah, the AI is creating its own logic paths and optimization strategies that human engineers can barely trace or comprehend anymore.
So the AI improves its own brain without needing human engineers.
That is the new reality. Humans are no longer in the driver's seat of the actual training process. We are just observing the results.
Let's synthesize this whole journey we have been on today. We started by looking at extreme physics constraints.
Right.
The physical limitations of copper wires forced NVIDIA into a massive pivot, bringing us light-based chips and incredible new speeds.
And that massive computational power, secured by tools like NemoClaw, birthed entirely new software architectures.
Yeah.
It enabled these complex systems of sub-agents to exist in the first place.
Right. It gave us the foundation for these 7-layer Claude setups. These complex pipelines have completely replaced traditional prompting.
Exactly.
They're running entire businesses quietly in the background.
And now, Those very pipelines are evolving once again. They are turning into autonomous AI that writes its own code.
It launches its own startups.
Right. It relies on synthetic data to train itself to be smarter every single day.
It is a lot to take in. It is a complete redefinition of what work even means for us.
This raises one final highly critical question for you to mull over as you digest all of this. If an AI can now build a startup entirely from scratch, and continuously train itself to be better without our help,
Right.
at what point does human intervention go from being the catalyst of innovation to the actual bottleneck?
Wow. That is a heavy, lingering thought to leave on. Thank you so much for joining us on this deep dive.
It's been great.
I highly encourage you to look closely at your own daily tasks tomorrow. Ask yourself honestly, am I still just prompting, or am I building a system? Beat. Take care, everyone.